The temperature is negative 40 degrees Celsius. At this depth of cold, steel becomes brittle, and the Yukon River is a solid, motionless vein of ice. But inside the hull of Dredge No. 4. The air is a humid, oil-slicked fever dream. A 1,200 horsepower electrical hum vibrates through the floorboards, a low-frequency growl that rattles the teeth of the winchmen. Then comes the sound that defines the Klondike, the screech of the bucket line. 72 massive manganese steel buckets, each weighing 1,400 kilograms, begin to rotate. They bite into the permafrost ground that has been frozen solid for 10,000 years. The impact is not a clean cut, it is a violent, structural groan. The entire 3,000-ton vessel, a 4-story fortress of wood and iron, heaves. Massive steel cables, thick as a human wrist, snap taut under thousands of pounds of tension. If one snaps now, it will whip through the air with enough kinetic energy to bisect a man instantly. This is not just mining. This is an industrial siege against the earth itself. If you value these deep dives into the raw mechanics of history, please subscribe. Now, let us step back to the moment the Klondike Valley was transformed from a wilderness into a factory. By 1912, the romantic era of the lone prospector with a gold pan was dead. The easy gold, the dust sitting in the creek beds, was gone. What remained was locked inside the muck, a frozen mixture of gravel, silt, and ice that resisted picks and shovels like reinforced concrete. To extract it, the Yukon Gold Company didn't need men, they needed a monster. Dredge No. 4 was the answer. It was the largest wooden-hulled bucket line dredge in North America, a machine designed to move the earth on a scale that defied the geography of the North. The physics of the operation were simple but devastating. The dredge didn't sail on a river, it created its own pond. As the buckets excavated the ground in front of the hull, the machine floated forward into the hole it had just dug. Behind it, it spat out mountains of washed gravel tailings, effectively turning the valley inside out. The scale was tectonic. In a single 2-4-hour shift, this machine could process 18,000 cubic yards of material. That is the equivalent of a football field buried 10 feet deep in gravel, evaporated from the earth, and processed for a few ounces of yellow metal. The sheer mass of the machine required a delicate balance of buoyancy and structural rigidity. The hull was built of massive Douglas fir timbers, bolted together to withstand the torsional forces of the digging ladder. This ladder, a 100-foot steel boom, carried the bucket line down to the bedrock. When the buckets hit a boulder the size of a small car, the shock waves traveled through the ladder into the main drive gears and down into the very hull. The engineers had to calculate the exact displacement of the water to ensure that the 3,000-ton weight didn't tip the vessel as the ladder swung in an arc. It was a floating factory, a masterpiece of Edwardian engineering and a relentless destroyer of the landscape. The ice did not matter. The rock did not matter. The machine was designed to win. Section 2. The Anatomy of a Stationary Giant. To understand Dredge No. 4, one must stop viewing it as a boat and start viewing it as a massive articulated industrial limb. The heart of the machine was the main drive, located at the top of the digging ladder. Here, massive bull gears, cast iron wheels nearly 15 feet in diameter, converted electrical energy into raw, low-speed torque. The physics are staggering. To pull 72 buckets through frozen bedrock, the system generated hundreds of thousands of foot-pounds of force. Every tooth on those gears was a potential point of catastrophic failure. If a single tooth sheared under the strain, the entire 100-ton bucket line would lose its grip and succumb to gravity, sliding backward with a momentum that would crush the lower housing like an eggshell. The digging cycle was a masterclass in mechanical coordination. The dredge was anchored by 2 spuds massive steel-shod timbers located at the stern. Each spud weighed 24 tons. To dig, the winchman would drop one spud into the pond's floor, pinning the 3,000-ton vessel to the earth. Using the spud as a pivot point, he would then use steel swing cables attached to the shore to pull the bow of the dredge in a wide, sweeping arc. This allowed the bucket line to shave the face of the underwater gravel bank with surgical precision. The buckets themselves were not merely containers, they were reinforced cutting tools. Each bucket lip was made of manganese steel, an alloy that possesses a unique metallurgical property. It hardens under impact. The more the buckets slammed into the abrasive Yukon schist, the tougher the steel became. As the buckets reached the top of the ladder, they inverted, dumping their contents into a hopper. From there, the material entered the trommel screen, a rotating steel cylinder 50 feet long and nearly 10 feet in diameter. Inside the trommel, the physics of centrifugal force and high-pressure hydraulics took over. Powerful water jets blasted the rotating gravel, breaking down the frozen clumps. The cylinder was perforated with holes ranging from 1/2 inch to 3/4 inch. The pay dirt, fine sand, and gold fell through these holes into a complex system of sluice boxes and riffles. The heavier waste rock, or tailings, was carried up the stacker at the rear and dumped behind the dredge. This was a closed-loop system of total extraction. The water used for the jets was pumped directly from the pond at a rate of thousands of gallons per minute, creating a constant, churning slurry. The engineering goal was maximum throughput with minimum downtime. Any minute the bucket line wasn't moving was a minute the company lost thousands of dollars in gold. Consequently, the machine was built with a philosophy of over-engineering. Every shaft was thicker than necessary, every bolt was doubled, and every bearing was designed to be lubricated while in motion. It was a mechanical organism that never slept, designed to eat a valley and defecate mountains of sterile stone. Section 3. 12 hours in the belly of the beast. Operating dredge number 4 was not a job. It was a sentence of sensory assault and constant vigilance. The interior of the dredge was a labyrinth of unguarded flywheels, oscillating pistons, and grease-slicked catwalks. For a deckhand, the primary enemy was the noise. The constant 110 decibel thrum of the trommel screen and the rhythmic times, thud-clack times, of the bucket line created an environment where verbal communication was impossible. Men communicated through a series of hand signals and frantic gestures. Long-term exposure didn't just cause hearing loss. The vibration traveled through the skeletal structure, leading to chronic joint fatigue and a permanent state of neurological agitation. The physics of the machinery created kill zones that the crew had to navigate every hour of their 12-hour shifts. The most lethal were the swing cables. These steel lines were under hundreds of tons of tension as they pulled the dredge across the pond. If a cable frayed and snapped a recoil event, it would whip across the deck at supersonic speeds. There is no medical intervention for a steel cable strike. It functioned like a giant blunt force guillotine. Furthermore, the dredge was a vertical hazard. Open gratings and narrow ladders meant that a single slip in the negative 30 degrees Celsius mist of the gold-washing floor would send a man plunging into the freezing, muddy sludge of the pond, or worse, into the gears of the main drive. Then there was the invisible toll, the air. To keep the gears from seizing and the crew from freezing, the interior was heated by massive boilers, or, in later years, electric heaters that didn't circulate fresh air. The atmosphere was a toxic cocktail of evaporated lubricating oil, pulverized rock dust, silica, and, in the early days of gold recovery, mercury vapor. While Dredge No. 4 primarily used mechanical riffles, the legacy of mercury used to amalgamate fine gold hung over the industry. When silica dust is inhaled, it creates microscopic lacerations in the lung tissue. Over months of 12-hour shifts, this scar tissue builds up, a condition known as silicosis, effectively turning the lungs into inelastic stone and suffocating the worker from the inside out. Despite the brutality, the dredge masters were the elite of the industrial North. To run the winch room, the brain of the dredge required the coordination of an orchestral conductor and the nerves of a bomb technician. The winchman felt the machine through his feet and the tension in the levers. He knew by the slight change in the pitch of the motor if the buckets had hit a layer of clay or if they were snagging on a buried cedar log from a prehistoric forest. These men weren't just laborers. They were the human interface for a 3,000-ton prosthetic limb. Their skill determined whether the company saw a profit or if the massive machine would buckle its own hull against the frozen earth. They lived in a world of grease, ice, and thunder, trading their health for the Yukon's hidden wealth. Section 4. The Golden Scars of the Yukon. The golden scars of the Klondike are not hidden. They are visible from space. For miles along the Bonanza and Hunker Creeks, the landscape is defined by serpentines, massive, undulating ridges of white gravel tailings left behind by the stackers of machines like Dredge No. 4. This is the industrial fingerprint of a monster. By the time the dredge finally ceased operations in 1959, it had moved millions of tons of earth, fundamentally altering the hydrology of the Yukon. The natural filtration systems of the valley were replaced by sterile mounds of rock that will take centuries to revegetate. The machine didn't just mine the valley, it consumed the valley's future. Yet, the legacy of Dredge No. 4 is the foundation of modern Canada. The gold extracted by these mechanical behemoths, totaling over $300 million at historical prices, fueled the expansion of the Canadian West. It built the banks of Toronto and the infrastructure of Ottawa. The technical innovations born in the permafrost, advances in cold-weather metallurgy, high-torque electrical distribution, and large-scale hydraulic management became the blueprint for the massive open-pit mines and oil sands operations that drive the global economy today. We live in a world built by the data gathered in the frozen mud of 1912. Today, Dredge No. 4 sits as a silent wooden cathedral on the banks of Bonanza Creek. It is a National Historic Site of Canada, a monument to a time when humanity believed that no environmental barrier was insurmountable. When you stand beneath its massive bucket line, you don't feel the romance of the gold rush. You feel the weight of 3,000 tons of wood and iron. You feel the ghost of the 110 decibel roar. You feel the immense, terrifying ambition of an era that traded human lungs and pristine wilderness for the cold, hard certainty of gold. The machine is now a hollow shell, its boilers cold and its gears seized by rust. But it remains a testament to the raw power of the industrial age. It reminds us that progress has a physical mass. It reminds us that every skyscraper, every highway, and every gold bar in a vault began with the violent collision of steel and earth. The Klondike was conquered, but the price was paid in the sweat of the winchmen and the permanent displacement of the natural world. As the Yukon wind whistles through the empty bucket line, it serves as a grim metallic whisper. We can move mountains, but we can never truly put them back.